All right, so for example number 9, if we do example number 9, they give us an upper and lower boundary. So like we said on our last example, if they give us an upper and lower boundary, then that's a definite interval. Okay, so from 0 to 1, and we're asked to find or evaluate the area under the curve of this function here. Okay. Now this one is an interesting one because there might be a way that I could use U substitution to make this easier to solve. So I notice that x to the first power is a derivative to some degree of x squared. So I'm going to try and say u is equal to x squared minus 4, right? Is that what it is out of the book? Yeah. So then if I take the derivative with respect to x, du dx would then be 2x, and then the 4 goes away, so that's nice. But I have to address this dx, and then I have an x here. So if it's possible, I'd like to get that x dx thing worked out. So if I take and multiply both sides by dx and divide by 2, I get x dx. Right. And so the way that I got that, I can write it out if you want me to. I took this whole thing and multiplied it by dx over 2x, like that. Or actually 2, not 2x, just 2. So if I take this, if I take this and say dx over 2 and I multiply that through, on this side the dx's cancel and I get du over 2. On this side the 2's cancel and I get x dx. And so what that allows me to do is I could take the antiderivative of, so if I substitute some stuff in, all of this here becomes du over 2, right? And then this right here, I've got a 1 on the top. All of this right here becomes u. So I've got something that looks like this. So if I do some, if I apply the commutative property of multiplication, I can get something that kind of looks like that. 1/2 times du over u. Okay. And then notice that I'm not writing the upper and lower limits yet. So that becomes 1/2 du over u. Now we said that the antiderivative of that is going to be the natural log of the absolute value of u. Again, I didn't write down my upper and lower limits yet because I'm going to plug in all that stuff for u, right? I'm going to plug in all that stuff for u. So that means that to figure out or evaluate this business, I'm going to say the natural log of the absolute value of x squared minus 4 times 1/2. But now I'm going to plug in my upper and lower limits. That's what I was thinking, which was 0 to 1, I think. Yeah. So I'm going to say from 0 to 1. Now this is just algebra. I'm going to take 1/2 and leave that there. And I'm going to plug in 1, so I would say the natural log of 1 squared minus 4 minus the natural log of my lower limit, which is 0 minus 4. Okay. So then that becomes 1/2 natural log of -3, right, minus the natural log of -4. And so you might be tempted to just come into your calculator and say the natural log of -3, minus the natural log of -4, and you'll get no real answer. And the reason that you get that is because you cannot take the natural log of a negative number, right? It's not in the domain. So then we start to run into a problem. Well, the problem is that I made a simple mistake. It's supposed to be the absolute value. Now I did that on purpose because I wanted to remind you guys that we're going to take the absolute value of these. So instead of taking the natural log, and that's why that's in there, somebody asked me last hour why that was in there. We're going to take the natural log of the absolute value of these. So really, what we're going to do is we're going to take the natural log of 3 and subtract the natural log of 4. Okay? Now we'll get an answer, which is negative 0.287. Now we have to divide that by 2 because that would give us the 2. Because this right here, we've got to multiply by 1/2 or divide by 2. So now, so we get this negative 0.143 business. So this is like negative 1.438. Okay. Now you could leave it like that. That's the decimal approximation. I could also clean this up too. Remember that if I say 1/2 times the natural log of 3 minus the natural log of 4, you might see in the textbook that if I use the quotient property of logs, I'll have 1/2 times the natural log of 3 over 4. That's another way that you could write it. You can even evaluate this. So now to double check this, what I'm going to do is I'm going to graph the original equation, which was x, divided by the quantity x squared minus 4. All right, and then we're going to graph that. And it's well, it's kind of like, it's not quite parabolic, but I'm going to change the zoom to just a standard zoom so we can see it. And it looks like we have some pretty high values. So let's change the window. I think my calculator goofed up here. Let's graph it again and see what it does. There it is. So I'm going to zoom in because we want the area under the curve from 0 to 1. So I'm going to go from 0 to 2. And my y value was negative because the area under the curve was negative. So I'm going to go from a min of negative 2 to 0. And so let's graph that. And so what we're trying to calculate is the area under the curve from all this stuff here. And so let's let the calculator do that, and we should get the negative 1.4. So if I choose option 7, my lower limit is 0, my upper limit is 1. As it shades in that region, negative, oh, I'm sorry, I got the decimal in the wrong spot. Negative 0.1438. And I think that's how I had it calculated correctly. I just wrote it down wrong on the board. Yeah, this should be 0.143.